So welcome back to my workshop. Today, I'm going to look at a Millipede game. So, got the Millipede on here. Let's turn it off and on again. And we have something happening here. There we go. A bunch of static tiles. This generally means this garbage happens usually when the CPU is not executing code at all. Because usually when the CPU is executing anything, even if it's resetting somewhere there's bad RAM or a bad ROM or something, things will move. So what could this mean? Could mean the CPU clock is bad. The signal to the CPU clock is bad. Could mean the reset is stuck low. Could mean that the ROMs are just so bad that it can't execute any code at all. So, could be bad RAMs. Actually, usually bad RAMs won't do this to you, because you usually get some type of resetting. But let's figure out what's wrong with this board. So the first thing we always do is get out the multimeter, check the power. So, checking the power here. I'm going to check the power. I always like to check it on one of the TTL chips, or you can just check it directly on these rails. TTL chips generally, 74 series TTL chips. The top right corner is +5, the bottom left is ground, and you can see we got perfect voltage there, 5 volts, right on the dot, basically. So that's fine. Put that away. And let's check out the O-scope. So we have our O-scope, we're going to ground it, because the next thing we check out is, once we test the power, is to see whether we're resetting whether we got a CPU clock. So the CPU clock I like to always test first. Actually, I usually do the reset just because on this one it's easier, on the 6502. 6502, the CPU clock is 4 back from the top right. So 1, 2, 3, 4. And you see we have 5.1 megahertz. Good. That's what it should be. Let's also check the reset. And it is resetting. It's not stuck low. So the game is resetting, not stuck low. We do have a good clock. So, next thing I do is I fire up the Fluke, because now I'm going to test the RAM and the ROM. So take the O-scope probe off. We don't need that right now. We're going to go ahead and get that tape off my hand. I'm going to go ahead and remove that CPU pod, or CPU. Put the Fluke probe in. Remember, turn the game off. Fluke is off. And let's go ahead and put that probe in. Turn on the Fluke first. I'm going to go to setup. More. Active force line, no. Oh, bus test, but we don't have power on, so not turn it on. We do a bus test, and we see immediately data bits 5 and 6 tied loop. Now, this is very rare that you see this, because there's usually not many chips that directly can talk to the CPU. Usually only some buffer chips. And they're the first chip on that CPU sees. So this is clearly a problem. If the data bits 5 and 6 are tied, nothing's going to work. All right, so we have to figure out why that is. Often that can be if the board is physically damaged. Maybe there's a little trace bridge or a solder blob. I have some ideas because this is an Atari board using pokies. Let's go ahead and try to figure that out. So, data bits 5 and 6 tied loop. All right. I mentioned there's usually not many things that can do this on a board, but this is an Atari board. It's got the pokies, and the pokies, as I'll show you in the schematics, are usually often can directly talk to the CPU. They are directly on the same bus as the CPU. So, I always like to, whenever working on any game with pokies, I like to remove the pokies. Because they can give you, they do fail often, and they will mess up things. And most games will run just fine. Well, they'll boot without the pokies. The game won't work 100% correct. Like Centipede, it'll boot. You just will have mushrooms on the left side of the screen, and you won't have any type of sound. Millipede, I think, does the same thing. I don't remember. There's 2 pokies on Millipede. So I just want to test my theory. I'm going to go ahead and hit stop here. And let's go ahead and turn it back on with the pokies removed. Bus test. Okay. So pokies are obviously a problem. One of those pokies, at least one of them is bad. So while we're here, let's go ahead and do a RAM test. We're going to do a RAM short. On the RAM, the ranges for the 2114 RAMs. And on the ranges for these, right here and here, we have the 2101 RAMs, the video RAMs. So let's take a schematic, look at the schematic, and the schematic tells us what the RAM ranges are. So let's take a look at that. Okay, so here we have the schematics for the Millipede board. On sheet 3A, they give us the memory map, which is great. We see that the RAM in this first line is 0000 to 03FF, and then the playfield RAM is 1000 and all the way, well, there's actually 5 different ranges, but they're all contiguous, so we can just test them all in one group. So we can go 1000 to 13FF. Okay, so now we know the RAM ranges. We know that 2114s are in 0000 to 03FF. So let's do a RAM short on those. It should come back any minute. The RAM short's pretty quick, and it's okay, so that's good. Let's do a RAM long. I'm sorry, not a RAM long, a RAM short on the playfield RAM. And that is RAM short to 13FF. 1000 to 13FF. Yeah, let's take a second. We'll come back when that's done. So, looks like our RAM short is finished. RAM short of the playfield RAM. Let's take a look. It says 1000 to 13FF. Okay. Huh. That's odd. So, what could be going wrong?